Hey everyone, so this is the next section in chapter 7. This continues really closely with the last section of using the zero product property. So usually we have to do something called factoring first to get an expression in factored form. So factoring polynomials using the GCF, remember what does GCF stand for? Greatest common factor. And we've been doing greatest common factor ever since middle school. So factoring a quadratic expression is the reverse of multiplying two polynomials together. So that's really important. It's the reverse of multiplying two polynomials together. That's by definition. Remember, a greatest common factor is the largest number or quantity that divides evenly into all terms. What is the GCF? And then there's an example. What is the GCF of 8x squared y and 4x? So I want to start with just numbers here. Let me give you the numbers. 64 and 24. Okay, so 64 and 24. I want you to think of the greatest common factor between those two numbers. What numbers can divide evenly into 64 and 24? And we can go through and list the factors if you'd like. So I'd have 64, we know is 1, 2, 4. Does 6 go in evenly? No. And 8. Then I could have greater ones. But I know I'm only going up to 24 over here. So let's check out 24. I'll have 1, 2, 3, 4, 6, 8, 9, 10, 11, 12, and then that's all. Okay. Here we could have more. We'd have like 32, 16. Okay. What I want us to notice is the greatest common factor of those two numbers, and hopefully we can see it. And that's going to be 8. Right? 16 and 32 aren't on my 24 list. 12 isn't on my 64 list. So the greatest number that divides evenly into 64 and 24 is 8. So GCF over here is 8. Now, if I look at 8x squared y and 4x, how much do they both have in common? We can break it up with the factors. And if I look at 8, I could do 2 times 2 times 2 times x times y. If I look at 4x, that gives me 2 times 2 times x. How much could I take out of both of those terms? I'm looking at, I could take 2 2's over here, 2 2's over here, and then just 1x and 1x. And if I put that together, 2 times 2 gives me 4x is my GCF. That's as much as I can take out of both terms. Okay, 8 and 4, I could take a 4 out, and I can only take an x. They both only have an x in common. I can't take out more if the other one doesn't have more. And this skill of taking out the GCF is all we're learning in this section, and it's really important. Okay, so use the reverse of the distributive property to write polynomials as a product of the GCF and its remaining factors. So it says factor the following, 2x squared plus 18x. I need to look at this term and this term to figure out how much I can take both. What's the GCF? That's what I need to do. If I just look at the 2 and the 18, and I think about 2 and the 18, I really don't want to have to write this list out every single time. So 2 and 18, what's the GCF I can take out of 2 and 18? Well, it's just 2, right? I could take a 2 out of 2 and a 2 out of 18. So what that looks like is that if we identify the GCF, so far I've got a 2, Notice I've got an x squared over here and an x over here. How many can I take out of both without going over, right? They both only have one of them in common. I can't take 2 out over here because this guy only has 1. So my GCF is a 2x. What we do is I factor that out of the equations, out of the expression, so I'm going to have 2x. And it really looks like division. So if I do 2x squared divided by 2x, if I take a 2 out of 2, I'm left with 1. X squared, and I take an x out, I'm left with just 1x left over. If I take a 2 out of 18, that's division, I'm going to be left with a 9. If I'm taking an x out of an x, it's gone, and I'm just left with the 9. Okay, so this is a tricky scale, but we're going to practice. Factor out the greatest common factor in the polynomials below. Okay, so 2x squared plus 4x. And so we can write out the factors if it helps. I'm going to have 2 times x times x. If I have a 4, I'm going to have 2 times 2 times x. What's the GCF? What can I take out of both? Well, they both have a 2, and they both have an x. So that's my GCF. I'm going to take a GCF out of both of these. And what's left? I'm going to have 1x left over and 1, 2 left over. And that's my factored form by taking out the GCF. Let's look at B. If I look at each of these terms individually, let's write out, actually let's do C. Okay, so I'm going to have 5n times n times n. 15, I'm going to have 3 times 5 times n times n. 20, I'm going to have 2 times 2 times 5, right? Because 4 times 5 is 20. So then I'm going to have times n. GCF here, what do each of them have in common? I'm going to have a 5 in each and nothing else, right? And then the variables, I've got 1 n over here, so that means I've just got 1 n I could take out of each. So my GCF is a 5n. If I take a 5n out, I'm left with n squared. If I take a 5n out, I'm left with 3n. Ooh, that's subtraction. And if I take a 5n out, I'm left with 4. There's my factored form. Okay, let's check out B here. If we want to write it out again, I'm going to have, so I know 18 is 2 times 9, so that's 2 times 3 times 3 times A times B. 12, I'll have 2 and 6, which is 2 times 3 times 3. No, 2 times 6 is 2 times 3 times 2. Times A times A times A times B. And then 9A is 9 times A. So that's going to be 3 times 3. And now let's look for my GCF here. I can have just 1 3 out of all of them. Because this one has 2 3s, this one has 2 3s, but this guy only has 1 3. So for my GCF has 3. And then how many A's? Well, this guy only has 1 A. So they only have 1 A in common. What's left over? I've got a 6AB. I've got a minus 4A squared B plus 3. Okay. Let's check out D. I'm going to erase part of this guy. Give me more room. Okay, D. Let's look at, we can break it up if that's been helpful. I can do B times B times B times Y times Y. B times B times B times Y times Y times Y. B times B times Y times Y times Y times Y. Let's look at how much I can take out. I've got 3 B's, 3 B's, 2 B's, so I can take 2 B's out of everything. And then I've got 2 Y's, 3 Y's, 4 Y's. I can take just 2 Y's out of everything. So my GCF is B squared Y squared. And then if I take that out of each of these quantities, I'm going to be left with 1B plus BY minus Y squared. Okay. It is tricky, but we've got to get in the habit of looking for these GCFs. Things to remember here. If the leading coefficient is negative, always factor out the negative. So here, notice the leading coefficient is a negative, so my GCF is going to be a -5. They each have an x in common. So then I'll be left with x squared. Take a -5 out of 10 is -2. X out of x squared is x. -5 out of -15 is a +3. X out of x is a 1. If the entire term is the GCF, the remainder is 1. So if we look at this one, I've got a cubed y cubed plus a squared y squared minus ax. They each have an ax in common. If I take out an ax out of a cubed x cubed, I'm left with a squared x squared. A out of a squared is a, x out of x squared is x, a out of a is 1, x out of x is 1. That's what it was talking about for this things to remember. Okay, let's pause here. That's just practice taking out the GCF. Great job, guys.